My name is Kristian Svennevig. I'm a geologist and senior researcher at the Geological Survey of Denmark and Greenland, GEUS. I study landslides in Denmark and Greenland and how climate change affect them. Well, I started in 2017 studying a giant landslide that occurred in West Greenland, a serious one that killed 4 people, the resulting tsunami. In a 5-year project, and while we studied landslides in Greenland, I got interested in how about in our own backyard in Denmark here. I didn't think there were any, but I looked anyway in the data, and I found 1, 2, 3, and started mapping all of Denmark, and I think we're at almost 4,000 now landslides in Denmark that we have mapped. Well, I mean, it is. We just didn't know about it before, and most of them are small and harmless on coastal slopes where they don't bother anyone, where they actually just make for beautiful nature and very diverse nature. But some of them are below built-up areas. Some of them have infrastructure on top, a few of them, and some of them were surprisingly large. Actually, we found active landslides that are around 1 kilometer by 400 meter big chunks that's moving by up to 5 centimeters a year, and we can monitor those using EGMS data. Well, in the Danish landslide project, it's really advanced our knowledge about some of these landslides, because before EGMS we just knew there were landslides. We didn't know if they were active, we didn't know which part of them were moving, but then applying EGMS, we could actually start to trace activity in the landslides, and we could see when the landslides were moving. And it became quite obvious to us, which is also known from elsewhere in the world, that these landslides react very much to wet winters. And it's interesting because in the future we'll have a lot more wet winters. When the groundwater is high, the landslides are moving. And we'll have a lot more of that in the future as a result of climate change. We could actually make that connection using EGMS data. I mean, it's really the time series that's important here, but also the map aspect of it, and that we get the activity of the landslides. That's quite unique. We can get that through other methods also. Some of them are expensive. They require us we go there and we install GPS stations on the landslides. We do that in areas to supplement the EGMS data. We can also subtract elevation models from various times, and we can see that the land kind of sunk in some places due to landslides. But EGMS gives the time series that makes it possible for us to clearly say that these landslides are reacting to climate change. I mean, it's a really nice product, so this is on the nice to have list. I also study landslides in Greenland, so EGMS in Greenland would be groundbreaking to have that. It's a large and complex country with a lot of terrain movement processes. I think a lot of researchers all around the world would be very interested in having that. So that would be high on my list and a lot of other people's. And then also longer time series. So now it's a running window. So you run 5 years, but we have data back to 2015. That means you could actually make a 10-year time series. That means we could start to study stuff that's moving much slower than we actually are with the 5-year interval. So actually having longer time series would be really awesome to make that available.